Hello, everyone. I hope you had a good lunch. We're skipping the siesta today. So, my name is Laila Bougria. I work for a company called Particular Software, where we make Service Bus, which is a messaging abstraction library. And I'm here to talk to you today about many of the struggles that I've seen teams go through when they start to adopt practices like messaging in their system. And at some point, I was on one of those teams and went through many of those pains myself. So you can find me on different places. You know the drill. It's either Noctavis or Laila Bougria. And OK, that being said, I'll start the session off with a story. Once upon a time, there was a retail business that decided to build an online shop for their system. And they started pretty small, but as their business venture grew, so did the system. And they quickly understood that in order to keep up with all of the changing requirements, the increasing complexity, that they had to start decoupling the system so that these things could be done in an easier way. So slowly but surely, because they went at it gradually, the system evolved into what we know as a distributed system. And that also supported their ideas to have multiple teams, so they ended up with 3 teams in the house: Team Lorem, Ipsum, and Dolor. For those of you who don't know, Dolor means pain, because there's always one team that feels more pain than others, right? As their sort of main communication pattern that they used inside this application, they chose to use messaging. Usually it's more than one, but for the sake of this session, let's keep it to this one. So let's take a look at one of the most crucial business processes as part of the system, placing an order. And we know the drill on this one. We want to store that order somewhere in a database. We also want to charge a credit card so we can actually make some money, right? We also want to package that order, ship it, and send the customer a bill so that they have some proof of their purchase. We also want to make sure that we adjust the stock based on the sale that was just completed. And we want to figure out maybe if we're close to depleting that product, then we want to order some more stock. We also may want to verify the customer status. Why? Well, if it was a first customer, maybe we want to send them a discount code so they'll be back tomorrow, right? That's how it works. Or if they were crazy enough to do like more than 100 orders in a month, then they're now a gold customer. So if you look at these sort of responsibilities within this business process in terms of the teams that were managing them, we have Team Lorem basically responsible for everything regarding that physical order. Then we have Team Ipsum responsible for everything regarding the stock. Finally, Team Dolor for everything regarding customer care, hence the name. So if you start to think about the system in terms of the messages that are flowing through it, right, commands, events that are being published, then you could come up with something like this. Sales component that can process orders, and then we'll publish that to the rest of the system. Finance taking care of actually making money, the inventory to keep the stock up to date, and so forth. But looking at this picture doesn't tell us anything about how the system works. It doesn't tell us anything about how these messages are flowing through the system, or who is handling what, who is responding to that. So to get a better understanding on how that works, we need to draw the system in terms of interactions. And that gives us a very, very different picture, also surfaces a lot of the complexity that's happening. So as you can see here, we're placing an order that comes into sales. At that point, when we can actually get the money charged off the credit card, we're going to publish an event called order place. So we're using the publish subscribe pattern here to basically signal to the system that something has occurred, and whoever is interested in that event can then subscribe to it and do whatever necessary actions are, they deem interesting to do. That also allows us to decouple things a little bit. So we end up with autonomous components. And one of the things that supports is having our teams that operate autonomously. What does that mean? Well, it means that the sort of components that they are working on can basically be managed by them, meaning that they can choose whatever tools, frameworks, even programming languages that best suits the need of that specific component, because that might be different. It also means that these components should be able to operate in isolation. What does that mean? Well, if one of those components becomes unavailable for a while because it's getting an update or just died for whatever reason, then the rest of the system should be able to continue operating without too much friction. You might get a buildup of some stuff that you need to get to later, but the system shouldn't come crashing down, right? And as long as the interactions between these components are based on a well-known contract, they can also evolve independently. But anything that can evolve independently can also fail independently. Let's take a look at one of the exception messages that Team Ipsum ran into. So this is a call stack, pretty simple. We're basically trying to get a product from a collection, and it does not exist. So the engineers on Team Ipsum are looking at this, and their minds immediately start racing through a bunch of questions. What happened? Where did it happen? In what specific context did this occur, and why? We'll look at the exception message and maybe see if there are any inner exceptions, investigate the stack trace to get an understanding of what's happening. Usually, debugging is the next step because that's how we can build up a sort of step-by-step context of what's occurring. What state came in? What state did we have available when we were making decisions? What were we calling? In what order? What did we pass on? And that's how we tend to understand the flow of a specific situation so that we can understand the root cause of problems. However, if you're running in a message-based system, you're going to have to ask yourself a few more questions because we need to understand which specific action started this chain of events. We also need to understand which components are part of that sort of business transaction, which components are involved. We also need to understand the specific chain of messages that was sent, and also in which order they arrived and how that may be impacting things. So let me step into the shoes of the engineer that was assigned this problem, and you can decide for yourself if I'm drawing from experience right here. So I'm looking at this exception, and I think, okay, product not available. I'll just quickly debug this. So I start to fill in component, and boom, immediately the exception pops up. So I start looking at the state that I have around, all of that. And I go look at the call stack to try to understand where I'm coming from, only to scroll down and understand that at the bottom of that call stack, I'm ingesting a message off a queue. So, okay, that doesn't work. Okay, no problem. I will just start the initiating component, and then I should be able to debug through this and F11, F10, step into the next method. It's not going to work either, because at some point, I'm sending a message or I'm publishing an event, and that means that that's going somewhere to a queue, and it's going to be handled by a different component. Okay. Well, you know what? I'll just start the entire solution with all of the components in it, and then I'll be able to debug it, right? Yeah, it's not going to work, because we decided to split everything up into different solutions, even place them in different repositories. Whose idea was that again? Okay, what else? Okay, I'll just start up 8 different instances of Visual Studio, Writer, whatever your favorite IDE is, if you're in .NET space at least. And I'll just connect the relevant things to the relevant processes, and then I should be able to debug through it, right? Not easy, but I have a very persistent character, so I get there. I'm sort of struggling with this for a few hours, probably. But I'm there, so I'm debugging through the whole system at this point. I have 157 breakpoints set all over the place. But okay, I'm going through it, and I have this gut feeling that I'm very close to catching the problem. You know, when you see it, but you don't fully see it, but you're like very close. Like F10, F11, I should be able to hit a 5 next breakpoint. And then everything pauses for a second, and I'm like looking at the state, and damn it, I forgot another breakpoint. At that point, with my Mediterranean roots, I'm already cursing at least 3 different languages, so I need a breather. Just step outside and just breathe in, breathe out. And I think to myself, come on, Laila, get it together. How can I fix this? How can I understand what's going wrong. I know, let me just add some logging. So I go back in, fresh energy, and I start adding log statements all over the place. And I'm debugging through everything and investigating those log statements and seeing, okay, order 257. Wait a second, wasn't I just debugging order 350? Is this message even mine? So I look at my colleagues and I ask them, like, is there anyone else creating orders on the testing environment? Because I'm debugging through something. And one of my colleagues looks at me in disbelief, says, what are you doing, Laila? Are you debugging the whole system? And I'm like, yes, well, I'm trying to figure this out. Do you think anyone at Amazon runs into a failure and thinks to themselves, oh, let me just fire up the Amazon and I'll debug through this? Well, okay, if you put it like that. But then the real question is, what do we do instead, right? Well, we test. And if I'm stating the obvious to you right now, then more power to you, but it's worth saying and saying and then saying again, because it's not something that we always consistently do, right? And testing is important, independent of any architectural style that we may be applying in our system. But if you're building a distributed system and you have a bunch of components that are interacting with each other, it's crucial. There's plenty of testing patterns and styles out there that are completely out of the scope of this session, but I'm sure you know plenty of them or know at least where to find them. There is something else about testing that I do want to pass along, specifically in the context of messaging. So I have this slide saying rethinking the rule of three. What's the rule of three? Well, I used to have here the AAA syntax, arrange, act, assert, because it's something that I've been using over the years. But it could be given when then, or if you just think about your tests in terms of preparing some input, executing whatever component that you're testing, and then verifying if that's actually doing what you want it to do. If we rethink that, then in terms of messaging, the first part is basically preparing that message. The second part is going to be invoking the message handler that's responsible for processing that specific message. And it's the verification part where things get interesting. Because not only do we want to verify that that message handler did everything we wanted in terms of data modifications, API calls, or whatnot, but what's more important is that we want to verify all of the outgoing messages that were sent as part of processing that message. Because that's how we're doing the handoff to the rest of the system, right? Not only which message, but also what content was in there. That's all good, but as always, the devil is in the details. And with the details, I mean the order. So one of the mistakes that we commonly make when we write code is that we tend to make a lot of assumptions about the state of the system. And it's a human thing to do, but it's not a good thing to do. Because if those assumptions don't hold up in a production environment, your handlers are just going to start failing one after the other, and there's nothing you can do about it at that point. So let's take a look at an example. Very naive stock update implementation snippet. So we're basically going to get the product from a product store, and if this message tells us to increase the stock, we'll do that. If we decrease it, also fine. The team also added a guard clause in there, because you can't have a negative stock, right? That doesn't make any sense. Nobody has -5 PlayStations in stock. So we'll just put that in there. But that is an assumption right there. Because is it really true that you cannot have a negative stock? Let's run through this for a second and zoom into part of the domain, the way it's currently set up. So the way it works now, when a sale comes in, we talked about this, we're going to charge it. And then when the order placed event is signaled to the rest of the system, inventory will go in and then update the stock based on that order that was sold. However, ordering can skew things. So imagine there's a very large amount of sales coming in at the same time. And you have a truck full of PlayStations that just arrived. And someone responsible for that went into the system and actually updated the amount in stock for our PlayStations. But you're doing so many sales at the same time that there's a message somewhere in that queue. If you sell a PlayStation at that exact time, we could run into a negative stock. And then what? Well, you could say, we're just going to introduce a sort of reserve stock message immediately when we place the order at the same time. We're not even going to wait for payment, okay? And although that might help, we're not going to completely solve the problem in a very large system with a lot of sales happening at the same time. We're just basically lowering the odds. So you might then think, okay, well, we'll just reserve the stock whenever someone adds something to their shopping basket. And that also has severe implications because I, for one, I like to shop around on plenty of web shops, put a lot of stuff in my shopping basket. Does that mean I buy all of it? Well, no, that would be very, very hard conversations at home if I would do that. So the question is, what do we do instead? How do we solve this type of problem? Well, we need to let go of the assumption that the stock cannot be negative, and that will open up new possibilities. So let's say the order comes in, right? And at that point, we're going to reserve the stock. Inventory will then say, hey, I have all the stock you need. It's all good. And then we can just continue our normal flow, ship that package, and everything is good in the world. However, if inventory at that point says, no, sorry, I don't have this available, then we could say, we're going to send a sort of timed message. And if you were in Adam's talk earlier, then you might have a little bit more insight about that. But we could send a message sort of to arrive in the future and then say, if we are unable to ship it within 3 working days, then we're just going to send you a refund. And it's not a crazy idea because a while ago, well, actually during early COVID days, I was shopping around for a screen for my home office, 49-inch, because reasons. And I was trying to find one in stock, and everything was depleted everywhere. So I finally found one shop that had it available. And I ordered it, just assuming that it would arrive the next business day, only to receive an email 2 hours later saying, sorry, we don't have it in stock, but we are going to back order it for you, and if you don't receive it within the next week, we'll just refund your money. So as a customer, you're like, okay, this sucks, but okay, I'll accept it and I'll just wait because my money's already gone, right? So these are real scenarios out there. And if you're looking at this picture and thinking about, but I have a better solution, maybe, possibly, but it doesn't really matter. Because what I want you to remember is to think about those assumptions that you are making. Try to find them and try to get rid of them and model for these type of events instead. Also, talk to the business. Because if you bring them an example like this and you say, we can't have negative stock, we're not going to sell anything we don't have, they'll tell you, well, of course you can. Get the money first. We'll solve that problem when we run into it. That's how businesses really work. So, okay, to sort of recap this first part, we want to test, and test some more. Whenever you run into a failure, you're missing at least one test, probably more. We also want to assert all of the outgoing messages that we are sending as part of processing a message, because that's how we can ensure that we're doing a proper handoff to the rest of the system. Be aware of any assumptions that you are making in the system. And one tip that has proven to be helpful in my experience, so I keep it in mind whenever I speak to the business and I can sort of reach a conclusion of how should this scenario behave, is I ask them, imagine there was no computer system. You just have plain books to manage all of this. How would this work if you had a physical shop and someone comes in and this happens? That might also give you some interesting insights. Because even people in the business are working with that system, and they also get stuck into the limitations that they have experienced within the system. Another thing is expect out-of-order messages, because they will happen at some point, whether it's due to concurrency or latency or a failure somewhere. Some things might just occur in the order that we don't specifically expect, because everything is disconnected, everything is asynchronous, and everything is communicating with each other. It's not as what we are used to in our monolith, that it's just one thing after the other in a synchronous order. Okay, so our teams take this seriously. Good testing strategy, very good test suite available. And at some point they say, we're ready for production. And it's been out there. It's been running actually quite successfully for a while. But then there's this guy, Murphy, that comes knocking down their door. And they run into a failure. So what do? Just said it, we're adding tests, right? Run into a failure, add more tests. But what if we look at the failed message, and we look at the message input, and we say, but of course this fails. This input doesn't make any sense. Let's take a look at an example. So this is the previous stack trace that we saw, right? We were trying to update the stock. We ran into an invalid operation exception because the product does not exist. But to understand how we got that data to begin with, we need to go up the tree and see, okay, the order packaged event, that was a trigger for that update stock message. But then we'll see, that was kind of just, for reaching over the order line, so no culprit there. So we go up again, one step. And that will lead us to the order placed event, and in there we can find out that the product IDs were incorrectly mapped. But imagine in a very large system where this 3 steps could be 15. How do we solve those types of problems? How can we understand this? Well, we basically need the big picture. It's not really helpful to focus on a very specific part to get an understanding of these types of problems. So instead, we need to be able to follow the business flow, or what I like to think of as a business transaction, across multiple boundaries, process boundaries, network boundaries, security boundaries, all of the boundaries, okay? We also need to be able to understand under which context each of those specific steps in that chain were operating with. What data did they have? What were they basing their decisions off? Basically, what I call zoom out, to be able to see, where does it look like there's something wrong, and then zoom in specifically there. And that is exactly what distributed tracing is for, which is now quite the hot topic today with the rise of microservices. But actually, it goes back to the beginning of the century, when service-oriented architecture was everything we were always talking about at conferences, right? It doesn't really matter what type of architectural style that you are using in your system. Once you have many decoupled components that are communicating with each other, that are basing decisions based on the data that's coming in, based on the information that they are receiving, we need to be able to understand how things traverse all those boundaries so we can basically understand the root cause of any failures that we are seeing in the system. So, okay, our teams, Lorem, Ipsum, and Dolor, they say, we can't do this if we're not doing distributed tracing. So if you remember, our teams operate autonomously. They could choose whatever tools they wanted, right? Because they're only responsible for a smaller part of the system. And within those boundaries, they can make whatever decisions that they wanted. So they start looking at what's available out there when it comes to distributed tracing, and they find that there's actually quite a few frameworks and tools available. And that's when they hit another wall, because you have Team Lorem that says, well, we're going to use Jaeger. And there's another team that says, yeah, but we already use App Insight, so we're going to go with that. The problem is that although they are collecting information that's very valuable, it's stored in a vendor-specific format. And at that point, they hit another wall. And it's problems like these that led to a higher need for standardizations. And as an industry, we are so good with standards, right? Because we just create a bunch of them. And then we have to support all of them, and we're still no step further. So what happened is we have, by the CNCF, we have open tracing as a distributed tracing specification. And around the same time frame, we had Google that open sourced OpenCensus. And then the vendors got involved and said, let's not play that game again. Can we just please merge these together and come up with one industry-wide accepted standard across everything that's available out there? And that's exactly how OpenTelemetry came to be. They basically merged these code bases, also taking into account users of each specific standard, took the strength of each, and that's how OpenTelemetry came to be. So what is OpenTelemetry exactly? OpenTelemetry is an open source observability framework composed of tools, APIs, and SDKs, and it's basically there to allow teams to collect and export telemetry data so that they can analyze the system's behavior and also get a better understanding of its performance. It's also available cross-platform, cross-runtime, which is really interesting in very large systems where you're using multiple stacks or platforms, because it doesn't matter which component. If you have a Java component and there's another .NET component on the other side, you will still be able to collect the same tracing information across those components. So I said observability framework, but what is observability exactly? Well, in order for a system to be deemed observable, you need to be able to understand the inner workings of that system. That means any expected state that it may arrive to, but to make things difficult, also any unexpected state. Basically, you need to know what you don't know, handling the unknown unknowns, right? You also need to be able to do that without changing any code or deploying any new versions of your application, which also means that we are going to store all of that telemetry information outside of the system. No going into the SQL database and querying all the tables and all that to figure out what's happening, okay? We also should be able to use external tools to the system to investigate what is happening. And there are three so-called observability signals that allow you to increase the observability of your system. There's traces, which we've been talking about now, but there's also logs and metrics. And I like to bring this up because sometimes when reading online, I've seen confusion and statements like, OpenTelemetry is the new distributed tracing. Well, not really. All of these three signals provide value on their own and can increase the observability into your system. Each of them provide value on their own. I would say, however, that traces are the most important thing because they give you that overview across multiple subsystems and give you that sort of zoomed out look, whereas logs tell you something specific that is happening within a single component, and a metric will tell you, there's a number here that represents something, but we'll get into that later. So let's start with the base, with what I find most important, traces. So what is a trace exactly? A trace basically is going to track the progression of a business transaction across all of those boundaries we talked about, right? Independent of any subcomponent. Think of calling REST APIs, calling databases, and all that. It's basically, you can think of it as a tree of spans. And a span basically represents one single unit of work that is part of that trace. It could be getting a message off a queue. It could be getting a product from the database. It could be even some processing that you are doing in your own application code. Each span also carries a context, sort of key value pairs that represent the important information that the system was using to base their decisions on at that time. But that's a little bit abstract, so let's take a look at a visual representation. Not a screenshot. I spent at least 2 hours drawing this. But basically, it represents a trace. So as you can see on the left-hand side, that trace ID is applicable to everything that you see on the screen. On the top right, you can see all of the components that are part of this business transaction represented by different colors. And you can see that we start in the browser when we create an order. Then we're going to send a message that's being picked up somewhere else, and so on. Does this look familiar? Because I like to think of this as a distributed call stack. We gave up our big monolithic call stack with all of the information that we used to have. But this way, we're kind of recreating it across multiple components. And it gets even better, because what we can do is we can zoom in into one of those specific spans and understand that context, right, that I was talking about. So as we can see here, I can see which message this is, and I can see, oh, this is being sent to the finance component, and it's being sent to a queue. So it's probably a command, because otherwise, if it were an event, it would be sent to a topic. I can also see some information about the order, and that gives me a lot of insight into what's happening. So if we circle back to that exception that I was unable to debug earlier, how would we solve that? So what we would do is we would go into whatever tool we are using to look at our traces, and we would find what failed, right? That would bring up those update product stock messages at the bottom right. And then those don't tell us anything, so we're basically going to traverse up the tree and then finally understand, look, it's when that order placed event was published that we can see that those IDs were incorrectly mapped, and then understand what happened there. So how does this work? Because there are so many different components and different languages. Well, basically, for a trace to be distributed and therefore propagated across multiple components, we are going to need some kind of a propagation mechanism. And one of the propagation mechanisms that's recognized by the OpenTelemetry specification is the, give me a second, W3C trace context for HTTP headers. I have no idea why they make it that long. I need like a full breath to say that. The only thing it really does is it adds a header called the trace parent, and that looks something like this. If we pull this apart, then we can see that there are some subsections. That first part represents the version of the specification of the protocol, sorry. Next up, we have the trace ID. This is going to be a unique ID that is assigned at the moment when that sort of business transaction starts, and from there on, it's going to be copied across every single unit of work that is part of that larger transaction. We also have a span ID that's going to be unique for each specific unit of work, right? Getting something from the database, ingesting a message off a queue. And then finally, we have some trace flags, and that gives us a little bit of insight into things like a sampling decision or something like that. Okay. Who's developing in the .NET stack? Just to get a sense. Okay, most of you, I'd say. So if you want to get started, Microsoft has made this easy for us because they built it into .NET. It's basically available in the System Diagnostics API since .NET 5 and later. But if you're using an earlier version of .NET, or God forbid the .NET Framework, plenty of successful applications still running on .NET Framework, right? Then you can still make use of this by pulling in the System Diagnostics source NuGet package. And it's super easy to get started because the only thing you have to do is set up a trace provider and select any sources that you want to collect information from. And then also set up an exporter so you can actually send all of that telemetry somewhere. Okay, if you're using something like the extensions hosting, so generic host in .NET, that could look as simple as this. So I'm using the OpenTelemetry extensions hosting package here, which makes that add OpenTelemetry tracing method available. And then I'm setting up that tracer provider. Important is to give your component a name that you're going to recognize. Because when you look at the telemetry data, you are outside of your application, and you want to be able to understand, when you look at a specific span, which component emitted that. I'm also setting up any exporters that I want. You can set up multiple ones, whatever best suits your needs. You could have even a different one for development and then another one for production environment. And finally, I'm also selecting the sources that I want to collect telemetry from. In this case, SQL client and Service Bus and the Azure SDK. Okay, this is also referred to as auto instrumentation because I'm basically just collecting information of the frameworks that I'm using. When it comes to exporters, there's plenty of options available. So I would say if you're already using one of these, and your safest bet is to look into how that could help move your team forward. If you're using App Insights, then Azure Monitor is really cool. I've taken a look at Honeycomb, really cool collaboration features as well. But it doesn't really matter, because the beauty of using a specification is that the specific tool is irrelevant. You're just going to choose whatever suits your and your team's needs best and go with that. And before you start adding application-specific traces, I highly recommend to go into that auto instrumentation that I just said, which means that look at the frameworks that you're already using today and look if they already support OpenTelemetry, because you'll find that plenty of them already do. And there's no need to start adding traces for example, getting a product out of a database, because someone already solved that problem for us if you're using Entity Framework Core or SQL client. So I think it's really important to first enable auto instrumentation. It also almost no effort, just the code that you saw earlier and sending that information somewhere. Look at that and see what value that gives you, and then enhance and enrich from there and add specific traces where they're actually going to add you some value. Okay, so if you're ready to really start adding some application-specific traces, then you might end up reading the documentation. So you look at the .NET documentation, and then you look at the OpenTelemetry documentation, and you get confused because there are some naming differences. Why is that? Well, that's because Microsoft decided not to reinvent the wheel and create a completely new API, but they basically implemented the specification in the existing activity API. That means that there's just a few terms that you're going to have to hardwire in your brain. So we have a tracer represented by an activity source. We also have a span that's represented by an activity in .NET. A span context is an activity context, and the attributes that we add to our spans are basically represented by tags. If you're building a system in which you actually are using multiple stacks, and you're saying, all these naming differences is too hard, then there's also a shim available that you can use so that the naming is consistent with the specification. Okay, so before we actually start writing any code to add traces, we need to start thinking about what type of traces we should add. So think of how many issues that we close because we're unable to reproduce them. Anyone ever done that? Whoever doesn't put their hand up is sleeping. We've all closed bugs because we cannot reproduce them, right? We even have banners for it, probably stickers somewhere. It says, works on my machine. Well, that's super helpful. Can you then ship them your machine so that they can use your machine next time they're using the system? Not really helpful. But what if you could easily connect a specific user action to a trace so that you can look at that information and get a way better understanding of what specific friction that user was experiencing and what error they ran into? Another question to ask yourself is, how easily is it for you to group similar traces together? Anything that deviates in terms of performance, in terms of maybe duration, or other specific tags that you have been adding to your traces. Another thing to consider is how easy is it for you to identify the most load-generating operations in your system? Are they maybe specific to a user segment, maybe to a location in the world? Is there maybe some infrastructure that you need to adjust in that part of the world where your system is catering to a specific user base? Another one is, can you identify which specific users are stressing out the system? What are they doing? In what order are they doing things? How may that be affecting any of the slowness that we're perceived? It's so much fun when someone from the business comes to your desk and says, system is slow, fix it. It's like, okay, what exactly is slow? For who is it slow? When is it slow? These are the types of answers that you want to get from the telemetry that you collect. And also, how easily is it to find suspicious event? So imagine that you wrote a bug. Imagine that, right? So you're like, okay, mea culpa, we'll just fix it, and we can deploy a new version. But then someone comes and asks, how many customers were affected by this? Because we want to send them a discount code and apologize in an email. These are the types of questions that you should be able to answer when things go wrong. So these are basically seeds that I'm trying to plant in your brain whenever you create an activity somewhere. And now we can finally look at some code. Okay. So if we actually want to get started, we're going to need an activity source, which is that tracer, right? It needs to be uniquely named. And you also can create subcomponents. So we could, for example, have an inventory.core, whatever, something like that, or an inventory.calculation, just saying something. So it's something to think about. And one of the sort of ways that I go about this is think, is what I want to collect, is that going to impact the amount of traces? If the answer to that is yes, is I want less traces to be created, then you need a subcomponent, which means you'll need a separate activity source. If it doesn't necessarily affect the amount of traces, but it rather affects maybe the tags that are collected as part of those traces, then you can work with configuration. I don't know if you spotted it, but earlier I was adding instrumentation for the SQL client, and there was a property there that would allow me to collect the SQL statements that were being generated. So that's configuration. It's not a subcomponent. So something to keep in the back of your mind. When you think of OpenTelemetry, it's an opt-in model. So it's not because I'm creating activities that you're also actually collecting them. So what you then need to do is add source. And what's important is that those string literals match. And if I actually want to create a trace, then what I'm going to do is I'm going to use that activity source that I created, and I'm going to start an activity. That activity is nullable. Why is that? Well, it's a performance optimization, because like I just said, it's an opt-in model. So it could be that nobody's collecting that telemetry that I'm creating right here. And in that case, then we don't want to be instantiating any objects and creating that memory overload that nobody needs. So it's just something to keep in mind. I'm also making use of the using statement, not only because I want to correctly dispose of the activity, also because I'm lazy and it's going to call stop activity for me. So I don't have to remember to do that. And then I'm finally going to add tags. And this is really important. That's that sort of key value per dictionary that is going to contain the context about this specific unit of work. So one way I like to go about it is when I look at some code, I think to myself, okay, let's try to imagine that there was a problem right here. What would be important to me? Which variables, which parameters are important to me right here? And those are usually the ones that are interesting to add as tags. Always a balance, of course. You can also over-emit. You can also add events, which is like a very sort of lightweight logging type thing that you could think of to sort of signal small things that are happening. And actually, I'd say this is a very bad example, because if you would actually have a stock recalculation starting and completing, that definitely needs its own trace. Its own span, its own activity that would be started so that you could see how long is that taking. Then I'm also catching any exceptions that might occur, and I'm using that opportunity to set specific tags. So if you look at the .NET implementation, you will also see that there's an activity.setError. Be very careful with that one, because sometimes it will set these tags depending on which auto instrumentation libraries you're using. It's a little bit weird. So I just try to play it safe, and I set the specific tags whenever an exception occurs. Why is that important? Because that is what's going to make those traces show up in that exporter as failed. Okay? Don't forget to rethrow. Okay, so to circle back to when we are creating this activity source, I didn't even mention the version there. Not because it's not important, but because I wanted to get back to it. Because any telemetry that you add to your application is going to evolve too, because your system is changing, right? And as that happens, so is the telemetry that it's going to emit. And it's really important to make those changes explicit because they will be available when you export them. So whatever tool you're using, you can see, okay, this trace was emitted by inventory 0.9 whatever, and this one is from version 1, which is really important in those larger systems where you have components and you maybe even have continuous deployment set up. You need to be able to understand which version created this friction. Okay, so our teams are doing this for a while, and they start looking at their code and they say, you know, this looks a lot like logging. So they start questioning things and they think about, should we just stop logging altogether? Is that a thing of the past? Well, no, because as we discussed earlier, OpenTelemetry is based on multiple observability signals, traces, logs, and metrics. Each of them bring their own value. I would say, however, that traces are very, very important. I already said that at the beginning. So focus on tracing first, especially if you're working in a distributed system. And then you can also log more verbose info. You may also have people in your team that are very used to working with logs already. So there's no need to stop. And actually, we have been logging in our applications for years. That is not a lost effort, okay? There's one thing that we need to do, connect those traces and those logs together. And then we have multiple telemetry information to look at that's actually connected to each other. So again, if we're in the Microsoft stack, using extensions logging here, that could look as simple as this. Basically setting up OpenTelemetry. What does that do? It's going to apply the OpenTelemetry logging format to all of my log statements that's going out. And that would look something like this. It looks a lot more structured, but what's really important is that it adds a trace ID and a span ID. So now you can connect that information together. If you're looking at your logs and you see something odd, then you can see, oh, that's the trace ID. Go back to whatever tool you're using and then say, okay, let me find that trace and see what happened, what context was captured there. Also the other way around. The way that this works is it's basically going to see if there's an activity.current available, and then extract that information, add it to the log statement. Okay, so we've talked about traces, we've talked about logs, but there are also metrics. And I don't have a whole lot of time to go into depth when it comes to metrics, but there are a few things that I want to share about them. So think of metrics as scalar values accumulated over a certain period of time to represent a specific state of the system. So in terms of messaging, one of the things that we really, really like to look at is message throughput. How many messages are we able to consume within a second, a minute, whatever is of importance to us? Another one, even if you weren't using messaging, that's going to be important, is the failure rate. How many failures are occurring? And that actually makes a very, very good base for alerts. Because you could say, if there are more than 100 failures happening in the time span of 5 minutes, pager duty alerts everywhere. Someone wake up, there's something going on in the system, right? But it's a pre-aggregated measure, and what's a bit tricky about metrics is that there could be multiple parts of the system that are adding to one specific metric to signal something. So the way that I look at it is when a metric is out of whack, it's an indication of a problem, but you don't really know where, which is when we go back to those traces. Again, zoom out, see where's the fire, and then we can zoom in and try to put it out. So it's really good to do some proactive monitoring and not wait until the entire building comes crashing down, but it's more like placing a smoke detector in each room, right? Okay, so what's the catch? Because I've been telling you all of these glorious things about OpenTelemetry, but what's the cost? And I think this is very important because there is always a cost, right? In software, any good thing that we get, we're paying a price. The question is, what's the price? And are we willing to pay it? So, in terms of tracing, we are allocating additional memory, right? But it's an API that's built with performance in mind, so we're not going to be creating activities unless we actually want to collect them and things like that. But still, if you have a very high throughput system and something is happening on the hot path, definitely something to keep in mind, to consider. How is this affecting things? You're also going to have added latency, added bandwidth use, because all of that telemetry we're collecting, we need to send it somewhere. If we don't store it somewhere, then why are we collecting it to begin with? Right? So we're going to use some bandwidth there. Costs are getting bigger as I go through the list, because that's how it works, right? Storage. We can still say, disk space is so cheap these days. But if you're Amazon, then that's a lot of telemetry, right? So it's also something to consider. There's also new tools that we are introducing. There's these, tracing tools that people need to work with. There's a license cost that comes with it. Some are free, some are not. And it depends, right? You have to educate your team, not only in how to use those tools, not in how to create traces, that's the easy part, but what to add traces for. What makes sense? What doesn't make sense? Right? All of those questions we need to ask ourselves. That's a hard exercise. It's not just, you create an activity. And those are really the difficult questions that we need to ask and the hard problems to solve. And then finally, the biggest cost is maintenance. Because whatever code that you write, whether that's production code, or it's test code, or it's telemetry code, that is going to evolve, which means that people need to keep it up to date, people need to change it, and that's usually the biggest cost, right? Okay, does that mean that you don't have to use OpenTelemetry? Well, I just spent an hour saying that you should, but I just find it really important to make you aware of the cost, so that's also something that you can consider. And there are some additional benefits, because I've been coming at this problem from something happens in the system and I don't know how to fix it. I don't know what's going on. Failure, investigation. But there are more benefits that we get from increasing the observability in our system. And one is the ability to perform postmortems. I know, very dark word, but think of a Black Friday, Cyber Monday, right? Everything went kind of well. We sold a lot of stuff, and the system became a little bit slow there, but nothing terrible happened, nothing caught fire, nothing completely died. We were still able to charge all of the credit cards. But we can still go back and see, how did the system perform? Did we scale up or out sufficiently quickly? Is there anything else that we can do next time to improve our system? Another one is feature flagging, because if we think of very large systems, then we don't always just want to introduce a feature and just roll it out to the entire user base. Sometimes we just want to introduce a feature to a very specific user base, see how they react, see if it works, right? And then take it from there. But if you have plenty of those and something goes wrong in the system, we also need to understand which features were available, which features were turned on, which combination of features was turned on, and how is that maybe affecting something. And then the last one is chaos engineering. Also, hot topic. Who's heard of chaos engineering? Okay, who's used it? Okay, smaller group. Well, it's basically a way to unleash chaos on the system, right? What the word says. But what it really means is that we're going to push a system to its limits and see where it breaks first and see what happens. How do we bring it crashing down? With services like Chaos Monkey and Azure Chaos Studio, we can do this now. But imagine not having any observability in the system when you do this, and then something breaks. we're not going to debug through 1,500 services anymore. We learned our lesson, right? So having that observability in the system is really very important. Okay, reaching the end, so it's time to recap. I hope I've poked your brains about observability in your system and how important it is to have that, especially in today's system landscape where we build distributed systems. And I like to think of observability as a way to recreate the call stack that we gave up when we said, we want smaller components, right? Because then there was also a cost when we made that decision. That big call stack that made it very easy for us to understand what's going on is gone. But this is a way that we can recreate it. Does that mean that we're never going to debug again? Not really. But if something happens, then we can go look at our traces, get the big picture, see where is something going wrong. Once we understand the scenario, we go back and add tests, right? Remember, we add tests. And sometimes we'll write those tests and they will fail anyway. And at that point, we'll just resort to our trusted debugger and see what is happening. But it will be localized and hopefully pain-free, not as painful. That's what I was telling you about in the beginning. So I would incentivize you to investigate the telemetry that's emitted by any of the frameworks that you're already using today. See what information that gives you. See what value that adds. Connect those to your existing logs if you were already logging. And then see what happens. Also, no need to go back to your manager and say, I need 3 sprints because I need to add observability to the system. No, you can do that slowly, enhance and enrich, right? Find what is most important, where do you have gaps, where do you have blind spots, and start adding tracing there and just go with it. Okay, that was it. I hope you enjoyed the talk. You can always find me online. We also have a booth available here at Particular Software. If you have any questions, feel free to ask. You can also scan the QR code. I have plenty of additional resources available there. If you're interested in observability specifically, like even independently of OpenTelemetry, which is a specification and a framework that we can easily just learn how to use with the documentation that we have available on the Microsoft website, but you want to dig more into observability itself, then I also have plenty of resources around that available. And I think Honeycomb is also upstairs, and they have a really cool book about it as well. So thank you a lot for listening. If you have any questions, I'm happy to hear them.